In this video, I want to do just a quick intro about experiment 4, water and hydrates. Let's talk about those types of molecules just a little bit. The two specific ones that we'll be using are actually listed here. This is part A, and we'll use the magnesium sulfate in part B. And they're very common, okay, this class of salt. And in the molecular formula, not only do you see information about the ionic compound, but there's also this little dot, and a certain number of water molecules. So what this is trying to get across is the idea that the water molecules are actually trapped within the crystal lattice of the salt. Okay, so, and you'll see this in the video, especially for part A, this blue solid, it's a crystalline material. It's almost powdery. And so if you held it in your hand, it would not feel wet. It would feel dry. But the reality is that, again, per formula, there are 5 water molecules in there. And with the magnesium sulfate, there are 7 water molecules trapped within it. And the nomenclature for this, the front end's the normal nomenclature that we're learning. And then on the tail end, we just use one of the Greek prefixes, penta for 5, deca for 10, etc. And then this term hydrate. And all that tells us is that there's water trapped in the crystal lattice. And in this lab, that's basically what we're doing. We take the hydrate, we heat it up, we get an anhydrous salt, meaning no water, and water vapor gets kicked off. In part A, you'll actually see the water being collected. Okay, in part B, there's actually not a video. I've just put the mass readings from the balances on the resource page for you to record into your lab manual. And I'll make note of the 3 different data points when we get to them in the report sheet. The reason why I made a video of part A is that it's a little more interesting than part B. Okay, part B is just a crucible being heated, and you really don't see anything being driven off, okay? In part A, there's actually a color change, there's water being collected, there's testing for that water, etc. And you'll see that in the video. I'm not going to spend a lot of time here on it. Part A is just what we call a qualitative experiment. There's just like color changes, etc. Just a descriptive chemistry. Part B, this is where we start doing quantitative. We collect numbers and then we have some calculations to make. And what you're seeing here basically is the formula that you're going to use. Let's talk about the equation just a little bit. So there you see mass of the water. That's pretty much self-explanatory. Once we look at the report sheet, I'll talk about how to determine the mass of the water. And then the mass of the original sample, what they're talking about is the mass of the hydrated salt. It's the first mass measurement times 100. And again, all you're doing is you're determining the percent of water in the sample. There's that qualitative label for the copper sulfate pentahydrate sample. And what you're going to see, I'll just do a little preview, it's going to turn from blue to white. The white color indicates the anhydrous sample. You'll see this setup in the video. You don't need to worry about this part. I will mention this a little bit because I didn't talk about it too much. I didn't do a full intro to it in the video. But basically, this is it's a little piece of paper, this blue. It's a test strip. And all it is a test strip for water. And when water is the sample that you're testing, then what you see is the test strip will turn from blue to pink. And it's a classic kind of color change to indicate that, yeah, the sample that you have in front of you is water. And in the tail end of the video, you will see this. I'll add a bunch of water back to the sample. It may be hard to see. I'll go ahead and let you know that it is an exothermic reaction. It happens very quickly, and it's not obvious, but there's actually some steam that's given off when the water's added to the white powder, and it turns blue. You may not be able to see it in the video. And actually, when you do the experiment, there's a hissing sound with the steam escaping. And that you can't hear. The hoods were going too, it's too loud to be able to hear anything. And then part B, again, is quantitative. Whenever you see a quantitative description, well, you're going to have numbers. You're going to have calculations, typically for some kind of quantitative analysis. Crucible, we'll see a crucible later on in an experiment. It's just a little clay dish. Put the sample in. It can take a lot of heat, heated directly in the Bunsen burner flame. And it's a process of a couple of heatings and coolings. And each time you cool it, you weigh it. Let's look at the masses that you're going to collect for B. So it's not labeled, but this is part B, dealing with the magnesium sulfate heptahydrate. So this is going to be a mass measurement. Okay, it's number 1. This is also a mass measurement. It's number 2. And again, you'll see these images on the report sheet or on the data sheet. And all you'll do is you'll record the mass on the balance right here. So like I said, you take the sample, you heat it, and you drive off the water. Well, oftentimes the first heating doesn't drive off all the water. Okay, so I did one heating and I did not record the mass for that, so don't worry about it. I did record the mass for the second heating and it was fine. And so this will be the third data point that you'll see. And then the third heating was not needed. Now, let me just sort of walk it through here. So this is the mass of the empty sample or the empty container. This is a container plus the hydrated sample. If you subtract those two, then you'll get just the mass of the hydrated magnesium sulfate. You're going to use this in the percent calculation. Right? Hydrated magnesium sulfate, let's go back up top. It's that bottom number right here. So to get the mass of the water, what you need to do is you need to take the mass of the hydrated salt and from that subtract the mass of the anhydrous salt. And that's going to equal that number, again, the mass of the water. Right? The only difference between those two is the water. You've driven off the water at this part, this mass a little more, that mass a little less. The difference is the mass of the water. To get the mass of the anhydrous salt, you're going to have to subtract the first mass from the third mass. Notice there's not a specific line here for this data point. And then the mass of the hydrated salt, well, that was just that part there. And then finally, for the calculation, there's your percent water. And please show the setup and the calculation. And this is just the equation that we looked at from page 1. So along with the report sheet, you'll also turn in the pre-lab and post-lab questions. This one, it's not a calculation, it's a conceptual topic. The procedure asks you to weigh out 4 grams. It's not a quantitative analysis or anything. It's just you're just watching the blue salt go to white when you heat it. So as long as you're close to 4 grams, you're fine for this. This question is very similar to the calculation in the report sheet. Post-lab questions, in terms of evidence about the sample, the water coming off. Did it look like water? What are the properties of water? Did it agree with that, just from your general knowledge? And then the other question is, the other answer part here would be the test strip. Does the change in the test strip confirm that it's water? This is in reference to the very end of part A in the video where I add the water back to the white anhydrous sample. Think about what you're seeing there, and then also the description that I gave in this video about the observations. Are any of those consistent with a chemical reaction? And then for the final question, think about what happens to the mass once all the water gets driven off. If you heat that more, is anything going to change? That's kind of put that in your own words here in this last part. And that's it.